Okay, so this video is going to cover the first section of Chapter 9, which is tangent properties. We just talked yesterday about some of the vocabulary that gets used around circles, and tangent was one of those words, where a tangent is just a line or line segment or ray that touches a circle at exactly one point. And so we've got two conjectures today. Make sure that you're finding some place to record all these. You're going to have quite a few of these conjectures for this chapter. And so having them in a nice, convenient place together is going to be really important. In class, we went ahead and did this review, little matching thing. So if you want to pause the video and do that matching, you can. And then I'll put up the answers here in just a second. Okay, so hopefully you've done that matching now. Take a look at the answers. So 1 is F, you've got congruent circles. E is concentric circles. Radius is C, so segment OE. The diameter is the chord is A, which is DC, right there. The diameter is AB, so that's D. A tangent line, that's line TG, so that's B. And then down here, a central angle is J, angle PTR, its T is the center. A minor arc is GRQ, so it only goes from there to there, just less than half a circle. A major arc would be I, PQR, because it starts at P, goes around the circle to Q, and then to R, that's more than half of a circle. And then a semicircle, H, is PRQ, that is exactly half a circle, P to R to Q. Now let's take a look at the two conjectures we've got. We're going to go ahead and do these explorations here on GeoGebra rather than doing the constructions by hand. The tangent conjecture is talking about what happens when you have a tangent to a circle and a radius that connects to that tangent. You can see a picture of what that looks like there. So if we go ahead and click on this exploration, open that up. If it'll load for me, there it goes. So what I've got here is I went ahead and measured the angle between those. It kind of looked like it was perpendicular, and it looks like, hey, it is perpendicular. Now, it doesn't matter if it only works on this one. Does it stay perpendicular no matter where I move it? And you can see I can rotate that around. I can make my circle bigger or smaller. I can change where my center of my circle is. At this point, I can't even move because it just depends on this circle. And it looks like no matter what I do, it always stays perpendicular. And so for this one, a circle or a tangent to a circle is perpendicular to the radius drawn to the point of tangency. So you put is perpendicular to right in there. And so this is really nice. Anytime you have a tangent line and you've drawn a radius in, you automatically get a nice 90-degree angle. And you'll see a couple of those in the examples. The second one has to do with when we draw two tangents, and we're specifically talking about tangent segments now. And so a tangent segment is a segment that is tangent. So tangent segments from a circle to a point outside the circle. So it only works if it's one circle, one point, and then two tangents, one on each side of that circle. So when you see a situation like that, what does it look like those two lines are? The yellow highlighted and the green highlighted. Well, let's take a look real quick here. I'm going to open this up. And it's going to take a second for it to load. But at this point then, you can see what I've got here. I've got a circle. You can see that no matter how I move the circle around, those two segments always stay the same length. If I move point C around, they always stay the same length. Obviously, if I go inside the circle, that doesn't work, because a tangent can't go into the circle. But no matter what else I do, those two segments always stay the same. And so our answer here, tangent segments to a circle from a point outside the circle are congruent. And that is another really nice one to have, because we know that a lot of things about congruent segments. If we were to make this into a triangle with these two segments and a triangle like that, we'd have an isosceles triangle. The way it is now drawn with the radius, because we've got congruent segments there and there, and we've also got the radius there and there, we've got a kite. And in this situation, because these are radii, these are 90-degree angles. So not only do we have a kite, we have a kite with 90-degree angles. We have two right triangles. We could use any of that trig stuff we learned about earlier to solve these. We could use Pythagorean theorem on this. Lots and lots of different things that we could do with this picture once we know that these are tangent lines. So let's take a look at some of the examples you're going to see. So in the figure, you've got TA and TG are rays that are both tangent to circle N. A major arc is formed by the two tangents. This one right here is 220. And we're supposed to find the measure of angle T. Number one thing I'm going to suggest, especially if you are looking at this on a computer screen or in a book, is to draw this picture. On the test, you'll obviously have the picture right there for you to write on, but it's a good idea to draw that picture out. So let's just go ahead and look at a few things that we know here. We're interested in angles, so that could help us out. First thing I might look at is this circle. I've got this arc, this major arc at 220. I could use that to find this minor arc. Right? If I just took 360, because the whole circle is 360, minus 220, I'd end up with 140. And so I know that this arc here is 140, which means that this angle inside, this central angle that intercepts that arc, has to be 140 as well. I have radii and my tangent lines, so right off the bat, I know that that makes 90-degree angles. And if I'm looking at this picture here, I can also see I've got a kite. And I know any four-sided shape, kites included, have angles, four angles that add up to 360 as well. So I can take 360 minus 90, and minus 140, and whatever that is, in this case it's 40 degrees, is the measure of angle T. So T is 40 degrees here. Take a look at something like this. We're using some similar ideas here. We've got that major arc, kind of the pink one there, is 245 degrees. This 35 degrees is for this angle in the corner of the triangle, and we're trying to find x. Now, there's a couple of different ways you could do this. Most people so far have been going with using this triangle here. Let's undo that. I can make those better. So that triangle there. And the big thing is, if I know that this arc around the top is 245, I could use that to find that arc right there. Because 360 minus 245 is 115. 15. So this arc in green is 115, which means this angle, the central angle, is also 115. That's that whole angle right up there. And now I've got 35, 115, and x. I can just take and use my triangle sum theorem. So I can take the 35 and the 115 away from 180. And here you get 30 degrees for x. Again, if you can draw on this picture, write down the things you know right on the picture, highlight things, look for triangles, look for quadrilaterals. That is going to help you out a lot. Finally, closing question here. Is triangle EGN congruent to triangle EAN, and how do you know? So take a second, pause the video, and we will come back in a second to talk about that. Okay, so hopefully you've got a chance to think about some things that you know in this picture. I'm just going to go ahead and mark them down. If I'm looking at this picture, first of all, I see radii. In a circle, any radii are going to be congruent to each other. It's always the same distance from the center to the outside. In addition, I've got this and this. My congruent tangents or tangent segments conjecture says that those two are equal. Other things I've got this side here, which counts as being congruent to itself. And I know both of these angles are 90 degrees. So at this point, I've actually got four things I know about these triangles. And so I could use SAS, or I could leave off the angle and go SSS. Either one of those is going to work, but they are definitely congruent. Finally, the homework here, there's only 6 questions. The first 5 are asking you to use those conjectures. The math you're going to do here is addition and subtraction with maybe some like dividing by 2 if you got to split something up equally between two things you know are equal. The challenge here is going back and using your conjectures. Right now you only have 2 of them. So when you see a picture like this, where you've got tangents, you've got radii, they're both meeting at the same point, think about the things that you know in a picture like this. Draw the picture and mark the things you know in. Then you'll be able to use the conjectures we've learned to find the missing things. Number 5 is a tricky one for a lot of people, but keep in mind, if I were just to look at like this corner here, if it tells me that OR is 13, because these two lines, OR and OA, are tangent segments, and they both attach to O, OA has to be 13 too. If I look at those congruent marks, well, that's congruent. P, C, and PA, those are also tangent segments. They're congruent. And the same thing with some down here. So you can use that information to find all the sides and then just add them up. Okay, and that'll be it. The answers to these are in the class notes down below the video link on Canvas, and you can take a look at those.